All right, hello again, everybody. Let me just get started here. What file is it? This one here. So we're going to look at, hopefully you find this just kind of a fun activity, and it'll introduce you to some digital design techniques. Just fair warning, I'm pretty new at this myself, the digital part of it, and so I'll try and walk you through what I've learned so far. And I showed you videos previously of some of the things I've made with this program. So I'll give you a chance to sort of play around with it too. So the submission is going to be the drawings and I'll see the files you make in Tinkercad itself. I'll carry you through and let you know all of the things as I go through the lesson here, all right? So basically looking at designing with orthographic and isometric drawings, but then also converting it to digital I should have on there as well. First task would be to design a thing of some sort. And I'll just, indicate here, I'm not using the smartboard today, so just bear with me a little bit here. You could make something like, a rectangle like this. So from a top view, maybe it looks like this or something. Super simple to start out with. So top view might be like that. Let's go front view, and let's say it looks like front view. There. So front view, I'm just going to make it real simple to start out with. So front view is that, and just this here. Then side view, make it pretty narrow, thin. I have this right here. Like that. See that right? Top view would mean that it'd be wider here, wouldn't it? That. All right. So, just make something, and then isometric version. I won't do that right now, but you can do that one later. Maybe I'll come back and do that. I guess I could. Let's just go ahead and do it. I lied. All right, so we've got 2 wide along there. Part of what you'll find with the isometric version is you have to come back almost later and delete some of the things. So if I'm thinking of that as like the base of everything, and then the one that sort of sticks out is sort of the base of all that stuff, then I need to have it be 3 units tall. So that's all the way up like that. For the side of it, and I'll go through with like a white pen and just white out parts that you wouldn't see because they'd be blocked by the shape. But I think that essentially is, probably shouldn't put this back one in because we won't be able to see it. I have to white it out later on, right? And then this little cube here, we'd have to fill it in, and unfortunately it kind of lines up too nicely with the other edge there, so it's a little hard, maybe a little hard to tell what's going on there. But if I were to get rid of some of these lines back there, I could just delete that one, I suppose. This one just needs to be shortened a little bit. So that is my thing. All right, so that's just a thing that I designed. You can do something nicer than that, I'm sure. But the next step is to create a digital version of that. And so we're going to use a program online called Tinkercad, totally free. Just sign up for an account, use an email, put some information in, whatever, and then use this class code, and you'll join my class. And so you'll end up on the trippy infinite screen there. So you'll end up being in this eventually. I have a class list for another class I'm doing. Anyways, you'll end up in there once you sign up, and I'll see your files. Okay, so yeah, I'll come back and show you some of that stuff in a bit. But once you're in the program, you're going to go like create new. You're going to make a basic shape. I'm trying to think of what this looks like when you first go in. What would I have to do that? Let me just go in here for CAD and go to design, new design, 3D design. and you'll just have a blank slate. You just make whatever. So I'll make that shape that I just looked at. So pull over a rectangular box. I'm not going to bother to make it all the details, but basically we want it to be, you know, a little. I could. Oops, that's the wrong part. So see how this works. Oh no, I want to do that one. So what I meant to do. Let's see if it brings me back or not. Yeah, it did. What I meant to do was the undo feature in the program, but I hit the undo or the internet version there, went to a different page. So I'm going to try and make that. And so I see what I'm doing here. I'm just sort of showing you by doing it. You grab these things and change the sizes and so on, right? So I wanted to make a model like that. This is the one, the weirder one. These are all pretty obvious. Move it left and right and back and forth, or however you want to think of those dimensions. But it's not going up and down. That's these ones. So these ones, you grab that little arrow and you can move it below the surface, or you wouldn't want to do that because if you're 3D printing, obviously it wouldn't be on things, but you line that up. So at 0, 0, it's on the deck. Here it's floating, which you'd have to put supports underneath it or something. Reason to have it floating, really, unless it's well, actually, like if you're doing a little car and you want to have it floating and have the wheels and whatnot, right? But anyways, that's roughly the shape that I did on the isometric drawing, and then you butt up a cube against it. See how that kind of worked. And then if you grab the corners, we can, you know, make it look kind of like it was, right? So then you can like look at this thing and be like, oh, it's not quite centered. I'll move that over a little bit and so on. Move it in and out from above. You know, you get the idea of how this works, right? You just try and make it as best you can. There is definitely some tricks there. It's showing you like 0, at least like I'd not sunk into it, and now I am. And then the -1 and so on, right? So now it's butted up against the surface nicely. Lots of things. It's fairly intuitive. Okay, so I was wanting to sort of center it more or whatever, but I keep ending up in the wrong spot enough, because once those labels are there, it's sort of hard to tell where you're at, right? But if I snapped this thing more to a certain grid line and then so on, that would be easier, right? So if I had that snap to a grid line and then had this expanded out to be, you know, 4 grids, then I'd be able to tell that this thing should be in the middle of all that stuff. So in the middle of those two and so on. So that's into the surface a little bit. I think that might be it there. Anyways, just trying to show you as I go here. Space there actually. Why is that? I thought the -1 was, I don't know whether it was attached or not, but you can always just sink it in a little bit too. It doesn't really matter. It just prints. So anyways, once you have that, there's your thing, right? If you're actually to try and print this thing, like on a 3D printer, if you have a 3D printer in your school, you can make a thing and go to the person that sort of is in charge of the 3D printer in your school. We have one in my school. I don't know if you have one or not, but if you do, you would group those together. So it makes it an object that's all joined and welded together. If you want to undo it to be able to modify things, you just click it and make it be separate and so on. Okay. Yeah. So other things to watch for, like if you wanted to have a hole down the middle of it, you can do that. I'll just show you. I don't have it in my isometric drawing, so I maybe won't leave it like that. But if I wanted to have like a little hole that goes down the middle, you take a cylinder like that and you convert it to be this, which means it gets rid of whatever it's contacting. And so this thing, if I move it down, you see like that's a whole board through the thing now when you print it. Okay. Anyways, so I'll get rid of that piece because that's not in my original isometric drawing, but there you go. That's the thing. And if you were to select it, group it together, and then go to export, you'd export it as an STL file. And you can I'll just save your downloads in your computer, and you can just literally just bring that to the 3D printer and print it. Keep in mind, you want to keep the sizes, right? If you were going to print something, you got to think about what size you want. I think you have an option. You have an option to switch the sizes if you're printing it, but here, you know, there's a certain grid size here of 1 millimeter per little grid. So I think each of the bigger squares is 1 centimeter. So this model you can tell is about 3 centimeters across and so on. A little harder to tell the vertical dimensions. Anyways, just giving you an idea of what this looks like and how it works. Okay, so literally just drag and drop and move things around, and pretty intuitive. I've had no training on this whatsoever. I just played around with it and The only thing I did get is I had to go and ask the guy that knows it at my school how to move things up and down. And that was this little guy here. So that once I got that, I was good to go. It was pretty obvious to move it left and right and back and forward and all that stuff. All right. So that's that part of the thing that I wanted to show you. Let's go back to the lesson. So just to show you another thing that I made, just to give you an idea of the possibilities. You know, what is it? It's just a thing, right? And this is you know, how I sort of steps and how I went through it and so on. And just to point out in the file, you have record of like the up or down and the height of the thing and the widths, and you know, and just pretty much just click and see what it does and figure out how to get it to do what you want to do. So in my system here, there's my thing. Whenever you make a new thing, if you don't name it something, it'll just name it whatever it decides. So it's kind of like some weird, I don't know, Swedish name, maybe like something at IKEA or something, a neat trug, whatever that is. But you can see what I did is I just had a rectangle and a cylinder and made a cylinder hole and so on and so on, right? So this one's actually a little out of place right now. The way I actually printed it, it was more like that, so it wasn't overlapping and down to, oops, I didn't really move it back and forward, so I'll undo that, just move it up and down. Anyway, so you can get an idea of print that thing. And so this thing's, I thought it was kind of neat. It has like a channel, a hole here that goes all the way through the block and up and taps to there and taps to there. So you could attach a hose to that and a hose to that. If this is a, you know, a part for a car or something like that, you'd have these channels inside. So just trying to give you an idea of, you know, what you can do with the program, some neat little things you can make. And certainly it could be, you know, just where is this thing here? It could be just a thing, or it could be something, if you have a part in mind that you need for a car. Like I had a problem with a Dodge van that I had one time with the fitting on top of the engine to do with the coolant lines. And one of them was just had a pinhole leak. So I ended up just buying a Y literally from the hardware store and just replacing it because the part from Dodge was like $300. And it's like, I could tell I could just hook the hoses back up. Anyways, I just jerry-rigged to fix. But I was thinking, man, I could have like designed a specific angle and everything else with this. Looking back on it, printed it and used it to fix the car. It would have been kind of neat. Anyways, so there's that. I'll just show quick here too some of the things. Like this is one of the things one of my students made just in class today. It was just a one period class activity. I was pretty impressed. She was able to do, or person was able to do there. Pretty cool. If I go any other ones here. Let's see if I had. Wow. I'd have to look and see what other ones I could look up. But anyways, you got the idea there. You can make lots of things. That staircase would have been harder to do the orthographic and isometric drawings of course. So maybe keep it a little simpler for that part of the assignment. But you know, by all means, play around and make some cool things. All right. Hope you find that interesting. I certainly did when I was learning it. Like, hey, that's how people make things with 3D printers. The program does have also, I should show you, when you play around with it, there's lots of things you can put like text in. You can type that, make that text be whatever you want. It's like gigantic now. But if you look, it just says text, right? And so you can type whatever you want and make a 3D printout of like a word. There's pre-built kind of models in here as well. Instead of basic shapes, there's like in vehicles and machines, there's like tires, you know, so you could drag in a wheel and use that. Oh boy, I'm not doing a good job moving this around, but I found out today, by the way, if you want to zoom into a particular area, you got to just have your mouse where you want it. So if I'm zooming in or out on that tire, it zooms to it. Whereas if I was way down here, it would zoom in below it. I'm just using the wheel mouse on there. That, and you can turn things various ways and so on. My main thing would be for you to be designing things, because one level, of course, is just finding a 3D print that someone made and printing it. That's just sort of, you're pressing play and printing. Whereas if you're the person designing the actual shape, that's kind of next level, of course, right? You're the person that's doing the hard work and the useful work rather than just pressing print. All right, so I will sign off there. That's a different lesson for the next day. I'll sign off there, and usually if you have any questions, just post them in the spot where we've talked about for the online class. Quick. I better not. I've got other things going on here. All right, that's it for now. See you later.